Welcome back to the Roll-Up High Roller community. As always, nothing on the roll-up is to be construed as financial advice. We are just some educators in the DeFi space. Toss us a quick like, give us a share, a repost, send it to a friend who may want to watch this, and finally, give us a sub or a follow. It means the world to help support credibly neutral educational content in DeFi. We're here to educate, empower, and enrich you, and let's jump in.
Misha, what's going on? Welcome to the Roll-Up. How's your Devconnect been going so far?
About 10 talks, I don't know, literally everywhere. So I'm done with it, but it was cool. It was cool. It was worth it. It was totally worth it.
What's your favorite zkEVM?
The one which has no security issues.
Which is your least favorite zkEVM?
You want me to call particular names or something?
I'm just asking questions.
It's like those ones which get audited, and then those ones which get reported as being hacked. It's like,
yeah, those ones suck. I don't like those ones. What's your background?
well, initially algebraic topology. I mean, then it's complexity theory, simplicial topology, yada yada, and here we go, like cryptography. Here we go. It's like the background. You want projects before that or something. Okay, I mean, BitMessage in 2013. I was hacking on that CITB implementation. Then it was like BitShares, a little bit of a Stimit. Then we had with Kostya, we had Russian dedicated fork of Stimit. It's like we've been running it for about 2 years. Still alive, still there, still works, just like Stimit is. So
Justin Trant.
yeah. He acquired Stimit back in 2019 or something, and then they forked out, creating a Hive block thing. It's where the original community went, and Stimit became filled with whatever Justin Sun has filled it with. So that's what it is. It's a long story, a long and complicated story, a lot of forks in there, like a big drama. That's the thing. And yeah, then April of 2018, Nil, and since then it's Nil.
So Nil for 5 years.
Yeah. It's like a lot of things happened within Nil if you want it, but in terms of for all these 5 years, but it depends.
What was the what was the price of Bitcoin in your earliest purchase in 2013 era?
Damn, sub $100. I don't even remember. It's like I was more on Litecoin back then, so.
People that were buying Bitcoin at sub $100 are sketchy, but we're just gonna keep that part of the conversation out of this.
Misha, you may want to hold the microphone a little lower, just when you talk. So I think my question is, because we were talking a little bit before this about zkSharding, and then maybe 2 years ago, maybe a little bit earlier, Vitalik transitioned the Ethereum roadmap from Sharding to roll-up Centric. So could you explain why he did that?
Okay. Yeah, that's actually quite, I would say, understandable, and that's it was a very logical step. The nuance is the transition to full protocol level sharding on L1 directly. First of all, it's very risky. Second of all, let's say this way, there were still back then quite a lot of design questions about how this should be properly implemented. So in fact, the transition happened from protocol level sharding to application level sharding. It's still sharding. It's just application level sharding. It's the difference is that like rollups are application level sharding, like in fact, okay, let's be honest. And the difference between that is basically you, first of all, it's like, okay, well, application level sharding works. I mean, it's fine, it's good. The nuance is that as we have learned over, I don't know, like a past year or something, the problem is that each of those application level shards turns out to be like, completely separate database, with completely separate liquidity, with completely like, isolated everything in there. It's like a modular approach, things like this, right? While protocol level sharding was supposed, and it is like always designed to maintain composability between different shards, and to something like it's like the whole and to maintain composability and to keep the liquidity unified. It's like not balkanized, something like this. So that's like the primary difference.
What do you mean by balkanized?
Well, it's like, let's say this way. Currently existing modular approach supposes for each rollup to get some liquidity, I don't know, out of ETH or like somewhere else, and to keep it in there without being able to share it to like more efficient execution layers or something if those appear, or like if those arise, for example. So it's like each rollup stays isolated walled garden, right? So that's like the thing. And one might say that I mean, this is being solved by like bridges and something. But bridges, okay, I mean, that's an application level composability, okay? Application level composability, each bridging, I don't know, how much would it cost you to, I don't know, bridge a single thing? $20, $30, I don't know, something like this. Between different rollups, there are no bridges, and they resist to building, to folks try to build those bridges. So that's like the nuance. There's also like another consideration, like some other like rollup projects try to push forward the idea that you can actually try to maintain composability between L3s by sending the transaction to a sequencer directly, and basically just putting the transactions between L3 coordinating that on L2, right? But nobody does that between L2s. That's the nuance. L2 is still separated. L2 is still isolated, and L3s, no matter if you put the transaction through the sequencer between different L3s, each of them still is a walled garden. So that's like it's like the primary problem. It's like no matter how hard you try with the modular architecture, with the current approach, you still hit the wall of like a walled garden issue. So that's like the thing. And we were like, hey, how could we I don't know, like, put together like the modularity idea, like keep the modularity idea to avoid the tragedy of commons, and in the same time, how can we keep the composability in there, and keep the liquidity unified, and to not to be balkanized. Basically, that's what it is. That's the first thing. Second thing is we used some kind of like as we try for the interaction between as we try for the interaction between like zkSharding as like more modern sharded execution layer for ETH to be as transparent, the interaction of applications deployed in there to be as transparent with original ETH as possible. That it means we try to prevent the liquidity outflow from ETH in this term, because we basically allow people to like read the data seamlessly from ETH, and next year most probably to write the data seamlessly to ETH as well. I mean, of course, the fees would be required to be paid, but like L1, L2 composability is something which is zkSharding also basically features to avoid balkanization of ETH, to avoid people tearing apart that thing.
Yeah, I think the big thing with the zkEVMs is that you can utilize shared provers and shared security mechanisms to kind of allow these different chains within a certain stack to kind of interoperate with each other. I know that that's something that like the Polygon team is working big on their zkEVM. Jordi often refers to it as constellations. Is the interoperability with zkEVM something that you guys see as like a big benefit for zkEVM? Is your LLVM kind of, let's say, zkEVM as a service? Is that kind of taking into account shared provers, shared security? Are you guys kind of helping to build that stack for people who want to use Nil to launch a zkEVM?
Okay, let's get into that. It's like I see a little bit of misunderstanding here in terms of what zkEVMs are in fact. Okay, so there is like a very common misunderstanding in this industry that zkEVMs are, like people confuse zk rollups and zkEVMs as themselves. They think it's the same, all right, but it's not. It's like zkEVM is just a circuit. I mean, it's just I don't know, like the description of an algorithm, mapped on a finite field. That's it. That's it. Like it's just a circuit. There is no protocol in there or something. It's like rollups are still yet to get their protocols to be established as a separate database. That's what they call, that's what the decentralization roadmap of theirs is what they call this. So there are no protocols in there yet. There are only circuits and just one node which processes data from itself to ETH via some circuit. So that's like the thing. No rollup is decentralized yet, as far as I know. No zk rollup is decentralized yet, as far as I know. That's like the thing. So regarding the zkLLVM on our side, yes, we use it to produce this circuit, not the protocol. It cannot process any other thing in a protocol. It's like the protocol itself is like a zkSharding stuff, right? It's like zkLLVM is being used only to produce a circuit, which proves the state transition of a protocol, like L2 protocol, back to ETH. That's like the thing. So can people use this compiler to produce their own zkEVMs to, just prove their state transitions to ETH? Yes, of course. And we have some interest from different rollups to use that. I mean, Taiko guys were talking about this, publicly, literally, I don't know, a couple of days ago or something at one of the panels. So just an example, or we had several inquiries, I don't know, whatever. So yeah, it's like people can use it.
So will Taiko have to pay or do some sort of agreement with Nil or XYZ zkEVM to use LLVM, or is it permissionless, open? Like how does that kind of structure work if Taiko wants to utilize Nil's LLVM?
Well, it's like zkELVM is just a software, okay? It's just a circuit compiler. It's like you're talking about the monetization strategy. Monetization strategy on this side, I mean, we cannot prevent them from, just taking the software and using it, okay? So in the monetization strategy on the circuit compiler level can only be done via the thing which we call a proof market, which we were running around for the last year before we went out that, hey guys, there's something which powers the market underneath. So that's the thing. And that's, and in fact, this is just a service for proof generation, as we call it. That's what it is. There's quite a lot of proof markets currently, and virtually everybody's building proof markets. But that's, was maybe the first one, and we've been with it for the year. And if they want to use it to, I don't know, increase the proof generation speed for their rollup, by relying on market dynamics instead of contracting somebody particular who would, get them some improvements, but how can you be sure that it's the best one can offer? Yeah. So if they want to use it for the sake of proof generation, sure, that's going to be the monetization strategy. It's open, permissionless. The endpoint for it is going to be deployed on ETH, I don't know, until the end of the year. Proof market itself is running on top of zkSharding. Once zkSharding is there in Q1, so that's the thing. So that's what it is.
So these proof markets are these zkEVMs, EVMs. Now, what is? And they're all kind of an organization of nodes, and they're organizing some costs and some incentives to generate these proofs. What is the missing piece? What it means for those proof markets and those zkEVMs to make those into full zk rollups? What is the missing piece to take those zkEVMs into zk rollups? Because you said there's no zk rollups that really exist yet. There's only zkEVMs. So do we need zk rollups, or why are these only zkEVMs and not zk rollups?
So yeah, I see what you're saying. So see, it's like, do we need for, you know, rollups to establish their protocols, like in general? Yes, it's like, because first of all, it's just data safety. It's just data safety, okay? But like but like, you know, one can argue that data safety is being guaranteed by ETH anyway, but there's also such a thing as liveness. So it's like state liveness. I mean, data on this, like, it's like data safety on L1 is being basically guaranteed by saving pieces of like each transaction happening on the rollup database side in ETH commit log. It's like in ETH, I don't know, like chain, whatever, beacon chain, right? That's the thing, like in cold data. That's the only way you save it in that. And but end users, whatever you do on a rollup, you need its state. You need its unpacked state. And its unpacked state is something which can be only guaranteed by a set of nodes which keep this state unpacked, and nodes which keep this state unpacked are basically nodes of a rollup protocol. So if anyone wants to, you know, like, if anyone wants for their rollup to be used by someone who requires liveness, who requires some SLA or something, then, I mean, you gotta have the protocol in that. It has to be decentralized. At least it has to be stable enough. It has to have at least, I don't know, like 5 or something nodes. It's like, but again, it all depends on the performance requirements or something. It's like, if folks have no performance requirements and they only serve, I don't know, just ease applications or something, it would be enough to have for such a rollup, I don't know, like 5 nodes or something. If folks target like high load use cases, I mean, like on our side, we do understand that would be required to have, I don't know, like hundreds of them. But like, luckily, we have hundreds of ETH validators. So it's like, we'll just go ask them. So, like, guys, you want to host that as well?
Yeah. So like, we're seeing like kind of these like sets of ETH, like EigenDA. They got a bunch of deposits of ETH, and now they're choosing to use their stake for DA and maybe restaking.
Yeah.
So very similarly, it sounds like Nil has a set of ETH and a bunch of validators, and you're choosing to apply this stake to a different use case. Is that?
It's like a bunch. It's like a bunch of ETH, and like, you know, to apply to different use cases in terms of, you know, just collecting the stake, which secures like the roll up and things like this. I mean, yeah, but that's traditional thing. That's like, you know, traditional thing which everybody does. So it's like, it's a little bit of a nuance. There is only a difference. The difference between different cases is only about the amount of this ETH. That's the first thing. And the second thing, the fit of a protocol, if it can be fit within the shared security system or not. So it's like some of the protocols and like the majority of rollups cannot be fit into a shared security model yet, because of the way their protocol function. So that's like the thing. So those ones which fit, I mean, they can use EigenLayer or something. Those ones which, you know, doesn't fit, I mean, okay, well, we'll just get security of our own. So that's like the thing.
So over the last couple of years, the ZK space has gone from basically an idea and white papers and a lot of cryptographic research to now, you know, actual practical functionalities, use cases. There's zkEVMs that have hundreds of millions of TVL combined, probably a couple hundred million across the big ones now. Where do you see this progressing over the next 5 years, and how are you guys planning to fit in?
Well, it's like, let's say this way, the bet on the circuit compiler is the future-proof bet of ours, I think, if we're talking about like, you know, ZK space in general, because besides, you know, the obvious ZK rollup application, there are, you know, quite a lot of applications of this thing, you know, out there. Like, you know, just one example is, I don't know, back in 2021, we have put out such a notion as ZK bridging. So now it has become a thing. And I mean, there are even projects which call themselves this way and like actually building a ZK bridging or something. So that's like, you know, the first thing. For example, another thing is there is quite a lot, maybe not really obvious, but zkML applications, you know, for like risk parameters, lending protocols or something. That's pretty obvious. So that's future proof, I would say. I don't know, like ZK oracles. Quite a lot of ZK oracles have, you know, they make sense because like as our as our recent Lido use case with the zk Oracle report and TVA, the report and total TVA have shown, there is different data aggregation needs DeFi protocols have, and the fact that these DeFi protocols are guarding billions of dollars, and security assumptions for them has to be reduced, and the only way they can be reduced is via these kind of zk oracles. So like, for example, the current zk oracle of ours guards, I don't know, whatever is Lido's TVL right now, 17 bill or something. That's like the thing. Or so there's quite a lot of applications of those, I gotta admit. And we even had a presentation like literally a couple of days ago with folks presenting zk Doom stuff. I mean, it's actually provable Doom. You speedrun Doom, you prove the fact that you speedrun it like in some particular time, and you present a proof of it without disclosing which tricks have you used to speedrun it in this particular time. So is it fun? Yes, it's fun. I mean, it's like, is it like, some economically viable application? I don't know, but it's fun. So even that thing exists, I would say. So I would say it's quite a future-proof bet.
Yeah, I think like any space with innovation, there's going to be a ton of new entrants in the space. I think there's a big barrier to entry with zk as far as the cryptographic kind of understanding that you need, right? I mean, there's tons of cryptographers who are working in this space, but if I were to take an educated guess, I would say that there's probably not that many in the world who understand cryptography to the level that you need to have a technical team to build a zk application. That said, there's certainly some competition in the industry now. Although we have an ethos of collaboration and pushing the industry forward, competition is healthy. So kind of regarding your competition, what's the unique edge that you guys have in the market or the vertical that you're looking to kind of, be the main player?
Okay, so if we're talking about like, there are basically two major markets which we are like currently at, and I don't know, we can just iterate over both of them. Okay, so it's like the first one is like a tool chain for zk applications market. So it's again circuit compiler improved marketing of ours. So this thing is, I would say, this thing targets those cases when there's a need for proven performance and minimization of a circuit size. Because I know quite a lot of folks are doing proving computations via manually defined circuits of a library, which, as you said, requires technical team to do this. It's not fun. It's expensive. It's just takes time. It creates friction between people in terms of when you coordinate and things like this. It takes time. Problem. It's like another approach is to, I don't know, like use just some general purpose zkEVM and to prove it to Ethereum, and that's cool, but the performance of that, you can't prove a lot with it. Okay, so it's not like fun. So from a toolchain perspective, we picked some middle ground between these two things. It's like we still can't prove high-level languages, I don't know, Rust, CPP or something, basically to Ethereum. But at the same time, there is no performance overhead induced by zkEVM because it's a circuit compiler. It produces plain circuits. That's like the nuance. That's from a toolchain perspective. From a perspective of, like zkSharding stuff, it's, again, it's like, I'd say there is quite a large green field in trying to, acquire high-load use cases on which, we're willing to work on top of ETH. Again, most trivial ones, programmable data availability is like, well, that's what it is. Builders, sequencers, this kind of thing. Like intent solvers, block future auctions. That's the thing. And, just pick at least one rollup which can process this kind of load within the unified monolith, not like monolithic, but unified execution environment. None of them. It's like, and it requires a lot of like TPS at least. So that's the green field we're covering with the zkSharding part of ours. That's the thing. I mean, obviously we can cover like, more traditional EVM applications migrating from ETH with the zkSharding stuff, but that's, very traditional market. I don't know if that makes sense to even like talk about it. It's obvious for everybody now.
You say there was a a use case with Lido in production. Could you explain that a little bit more and the findings there?
Okay, so what's this use case is about? So let's say this way. Initially, Lido was designed to be that way. So it requires the total TVL data from a beacon chain to be provided to execution layer by a bunch of oracles. It's like, let's not get into details why and who designed that, because Nil was also involved into that. But anyway, yeah. Yeah, it was a temporary solution. We just, like it was just put together in there. But in general, yeah. So in general, that was designed that way. So let's just leave it there. And it worked, and it was good enough for for those years which Lido was just developing, getting its users, making itself more popular, more interesting, things like this, right? And it was fine because these oracles were ran by the same validators, same operators, which were handling Ethereum nodes. So it was kind of, fair trust assumption that, if they want to screw up something, they would have screwed up with everything like a long time ago. So it was a fair trust assumption. Now, when Lido is basically like a backbone of the industry, the need for, reducing these trust assumptions came up. Because, the less trust assumptions you have, the better it is. So about a year ago, the first implementation of such a zk oracle providing total TVL information from beacon chain to execution layer was implemented. It ran in test mode for some time, wasn't performant enough, so we decided to respin this project. It's like to reiterate this project with a more modern toolchain without zkEVMs. So we used a circuit compiler for that. And in fact, what this whole thing resulted into right now, it resulted into an oracle which reports total Lido TVL information to, from beacon chain to execution layer. So the issuance of staked Ethereum, and not only, but so the issuance of staked Ethereum could be done correctly and properly based on the amount of, based on the amount of TVL which stakers have locked. So that's the thing. That's what it is about. And we try to guarantee the liveness of a proof generation for this thing with a proof market thing, because it's like the proof has to be submitted as fast as possible. Okay, so we were like, okay, we'll use the proper tool chain. We'll apply market dynamics to accelerate that, as to those theoretical limits which are possible. So the combination of this, like a perfect use case for the toolchain, basically. That's what this zk oracle is about.
Very cool. I think we're going to put you on the spot here where you don't think and just answer, and you have two choices, and it'll be fun. Are you ready? All right. Optimistic or zk rollups?
zk rollups.
zkEVM or Plasma?
zkEVM.
Tycho or zkSync?
No comment.
Plasma or state proofs?
State proofs. Litecoin or Bitcoin Cash?
Litecoin.
Everyone says Litecoin.
I'm especially biased.
Satoshi or Craig Wright?
Whole P.
That's a trick question. They're the same person.
Oh yeah. Very funny. As I said, whole CD.
That's it. zk oracles or Chainlink? Lido or any other staking node operator?
What are you talking about?
Which risk is more important, centralization or bad security?
Bad security is worse.
Yeah, I don't know how to put that, but I was trying to get at a trade-off: speed or decentralization.
No, speed is better because speed guarantees use cases. Decentralization, yes, it's censorship resistance, but it's censorship resistant. But if nobody needs that, what's the point?
Yeah.
So,
UX or decentralization?
UX.
UX or speed? Kind of go hand in hand. Speed. He likes to go fast, this guy. Do you have a fast car?
I don't have a car.
And there we go, typical. I appreciate you sitting down with us and having some fun and explaining some technical concepts in a pretty easy to understand way, well, at least for us and hopefully our community that has been watching and following along. We also have a ZK Academy that we've been working on, 9 videos, kind of taking you from zero to hero, if you will, in the ZK space. So I definitely check that out and check out Nil. And yeah, thank you.
Thanks for having.
Cheers to the moon.